Welcome to everybody who's joining us. Please go ahead and introduce yourselves in the chat and make sure to send your settings to all panelists and attendees. We'll be starting in a few minutes. Welcome everybody who's joining. We'll get started in a few minutes. We're just gonna let people start signing in here, but as you join us, please introduce yourself in the chat. Send it to all panelists and attendees. Okay, I think we'll go ahead and get started. Welcome everybody to our second week of our K-12 Online Teaching Academy webinars. I am Stephanie Eichley-Chang here from the College of Education at San Jose State, and I will be co-hosting along with Brian Chung-Dooley, our communications coordinator. We are very excited to present to you today our speaker, David Goulette, who will be presenting using Desmos Activity Builder for live or asynchronous instructions and assessment, which he has a lot of great things prepared for you. It's going to be just a little bit different today. We're going to kind of try and hold your questions, and we can go ahead and go to the announcements. Sorry about that, Brian. We're going to go ahead and kind of hold your questions until the end because David has been very gracious with his time, and he's going to do some kind of Q&A live with people who choose to stay after 1:30 today. And so instead of our debrief breakout sessions we've been doing last week, we're going to try a different format today. So thank you to David for doing that. Announcements really quickly before we get started is, of course, this event is being recorded, and it will be available afterward, and Brian will send that out to you, as well as the resources that David will be sharing with us. Captions will be available in the recording, and live captions are available at the bit.ly address, which Brian will put in the chat. Your video and audio are automatically turned off today, and again, we're asking you to kind of keep your questions, and we'll do some Q&A time at the end. And then you can use the chat to communicate. And I'm going to turn it over to David now. Welcome, David.
All right, thank you. I guess I need to turn my camera on, start video, and I'm unmuted. Hey, welcome everybody. Thank you for coming. I am so excited to share Desmos with you. It's a tool I use often. I think it's a wonderful way to make math come alive. And I want to give you the tools needed to get started making your own stuff in Desmos as a teacher. So let me share my screen because we're going to get started right away. And just want to make sure you see, did it share correctly? You can see my my screen. Can you see it okay?
Yeah, you're all good,
Yes.
David.
Great, awesome, awesome. Okay, actually, for those of you on the call already right now, you're actually going to become students in just a moment. When you first log into Desmos Activity Builder, by the way, the URL is at the top. It's called teacher.desmos.com. You don't need to go to that right now, but when you log into this website, you can create a login or log in with Google. You see it says David Goulette in the top right. So this is how you can save anything you work on. And in your you can also save lessons in a collection. I'm actually going to show you how to make this later in the presentation, but I'm going to jump right into a collection that I have, which is Desmos Demonstration. And the reason is because you see this collection, Desmos Demonstration, including the 3 activities that we will open up. All of this is shared with you in the document that's attached to this talk. So this is roughly the document you will see, and you will find links to everything, including the link right on the first page that goes directly to this collections. And you are free to use, copy, reuse anything you see. I'm providing everything to you, plus lots of other links for further study. Okay, I want to jump right into a lesson. So let's click on Welcome to Desmos Activity Builder, and you are all going to be students. But before you are, have a look at this screen. This is the screen you would see when you are at the welcome screen from the teacher side of starting an activity. You create a class code, and then this is the code you blast out to your students, which you guys are going to enter in a second. But don't enter it yet. Hold on. I want to view the dashboard, and I want to show you a teacher thing. Before you even let students come in, one important button is you can anonymize their names so they can see each other's answers, but with low risk. They're not worried about their name being attached to their answer. And the other one is you can pace which screens students can see. So I am going to force you guys to stick to page 1 and 2. And you will be forced to only look at those 2. And it's a nice way to pace a lesson live or online. But here you go. Can you open another tab in your browser? And we're going to try this. I've never done a Desmos lesson with this many people. We're going to see how it goes. We're going to try to break Desmos and see what happens. So go to this website, student.desmos.com, and type in the code you see there. If you are on a device where you can't do this, that's okay. If you want to just keep following the Zoom, I'm going to show things from my end. That's good. But if you want a chance to see it from the student side, you can right now. You will notice your name has been changed to a famous mathematician or physicist or scientist. And Brian, if you could copy this into chat if somebody comes late and they want to come in. I'm going to take this down. If anybody wants to know the code to get in. I didn't think about that till right now.
I just added it in there.
Awesome. As students start to populate your lesson, you can see them on the left. Now they are anonymized. If I turn off the anonymize, you can see people's names. One suggestion I give, I didn't give you any instruction, one suggestion I give is have your students do last name, comma, first name, because you can sort your students by the time entered, or you can sort by last name. So if you want to grade something from this, it'll match up with your grade book. So I'll put it back on anonymize. Can everybody just look at page 1 real quick? I just want to say something real fast. So the plan for today, number 1, you get to be the student. You get to see some teacher controls and quick formative assessment features. By the way, it did say that this was about assessment. I'm focusing on formative assessment for learning. There are ways to do formal assessment that grades itself, but that's a little bit more advanced, but I gave you resources for further study. We're going to talk briefly about the Desmos graphing calculator. It's amazing. And how do you build an activity yourself? And how do you craft tasks that get students thinking deeply and communicating via the Desmos format? Quickly on 2, I just want to say some benefits of Desmos. Graphs and tables are interactive. Function parameters can be manipulated to see the effect. I'm going to show you that. Students can move from specific examples to generalizations via sliders. I'm going to talk about sliders. What are those? Tons of amazing activities are already available by amazing teachers out there that you can just borrow and use. It is possible to do quizzes and exams. It's more advanced. We're not doing that today. Students can see math in action. And the thing I love is you can do quick feedback, instant on-the-fly formative assessment, and student self-assessment. One thing I want to say is I am a big tech junkie, and it is so important that students have a physical interaction with ideas before they interact with a tech tool. And I've read about this, and I've found that it's true that students often move from the concrete to the pictorial to an abstract. notion of a mathematical idea. And I find that Desmos sits really nicely in that move from the pictorial to the abstract. So I'll have my students work with those algebra tiles in Math 2 first with their hands, and then we move to Desmos. Or sometimes a mix of the two. All right, students, so if you were my students, maybe I could say you are ready to go on to a welcome on page 3 and page 4. I'd like you all to answer those 2 questions for me right now. So I've restricted you to screens 3 and 4. It looks like lots of people are very happy. Ah, Peter Dirichlet, his favorite number is 42. That's correct. That was the right answer. You didn't know. Okay. Awesome. This is like screaming fast. I thought it might lag with this many people, but it's working wonderfully. Can you all briefly come back to the Zoom so you can see my desktop? Don't close the student activity. Just switch back to the Zoom for a moment. And I want you to see what I see. I just created a little, how are you doing? And I can see all of your answers on the left. And the answers you put in your boxes for your favorite number, I can see on the fly. And so this is a quick way that you can look at all the answers. There's a summary view. The summary view also allows me to see what page you're on, so I can quickly see how our students progressing through the activity. And I can even click on particular ones to see the answer of that particular student. Okay, so if you have a multiple choice, one way you can look at it is to quickly say, oh, wow, we got a lot of people who have never used Desmos before. That's fantastic. I'm gonna give you a high level overview today. And we've got some that are like really experienced and all in between. So that's fantastic. You're all in the right place. I'm gonna try to give you, I hope I give you each one of you something. Okay. A thing you could do, just an idea, is you can all go to page 5 right now. And of course you had no homework, but let's say you had homework. You could do a quick homework check if this were an online course and you weren't gonna grade everything. You could say, hey, enter your answer for problem 42 from the homework today and explain, write a sentence or 2 about how you got it. So you can see how it prompts you for that. And I want you to try 3 pages. I'm going to edit it and I'm going to force you to go to page 6, 7, and 8. Just to, oops, sorry, let me stop that. I hit the wrong button. Pacing, 6 through 8. There you go. I'd like you to quickly answer something for 6, 7, and 8. You don't even have to like finish it. I just want you to see that there are multiple types of questions you can construct for students to be engaging with the material. Wrong answers are appreciated because you can even, I can show the data about how to quickly assess whether the class is getting it or not. So notice the page 7 is a multiple select question. And 8 is one of my favorite things. It's a card sort. So you can sort, you can create any kind of sorting you want. You can even have some of the cards be graphs themselves. I just did it with numbers and words. But you sort them and drag one object over another, and then you can group them together. So this one is sort the rational numbers into one group, sort the irrational numbers into another group. You can take just a moment, come back to the Zoom one more time. I want to show you what I see. For specifically, I'll look at page 7. Check this out. If I go to the teacher summary, I can kind of get a viewpoint, a quick viewpoint of, oh, I can see that the students are totally getting that that's a rational number because it's written as a fraction, but some weren't sure that that's also an integer depending on how it reduces. And all real numbers are examples of complex numbers. So the correct answer, the most correct answer with everything, you can actually click on the answer key that I've created, and I can quickly at a glance see what students are choosing and give feedback. No worries if you weren't sure of the answer, it's okay. Now, if all of you could please, oh, actually, no, I'm sorry. There's one more I want you guys to look at. Can you look at page 9 and 10? Now, you don't need to answer these. I just want you to see 2 more examples. And notice on page 9, I've asked you to draw a line, and you can have a blank graph where they have to do a little bit of drawing. And if you click on the left-hand side, there's a little line segment feature, and it's asking you to draw a line with negative slope and positive y-intercept, and then explain. You don't have to do it if you don't want. If you feel like drawing it, you can. On the next page, and I'm going to show you some examples of how to make some of these things. On the next page, on page 10, now go to page 10 and notice that there's a graph, but now it's interactive. The 2 dots that are bigger, you can actually grab them and drag them, and you can ask and answer questions based on doing a thing with an interactive graph. Kids love these. They love these. Okay, can you all come back to the Zoom now? I want to show you a couple quick things. The drawing one, do you notice how I can see things that people drew, including smiley faces? I can click the overlay button, and because there's so many students, it's a little crazy. With a small number of students, you often can see at a glance where students are putting their answers. This one was not the best one for doing an overlay. I just want you to see that it's possible. And you can see individual responses and look at different ones. On the make them perpendicular, I can see where students' answers are if I look at all of them, or I can go to individual responses and see how students are doing on that question. One thing that I do in my class is once my lesson is over, sometimes what I do is I actually have the homework right in Desmos. So for example, if I click on the, hopefully you're with me in my screen. So look in my screen, and if I cancel this, if I stop it, I'm sorry, you now have the ability to go to any page. And I actually have just created like mock homework questions that would be in the rest of the activity. And the last one just takes them to another thing. You can put in links to like IXL or their textbook or whatever. Okay, that was just an overview. Can you all come back to the Zoom? And I want to, because some of you said I've never seen Desmos. I want to quickly show you why Desmos is so powerful. Now I don't have near the time to do this justice, but I want to show you some examples. So the first tool that underlies all of this is Desmos Calculator. It is a graphing calculator that's freely available online, and you're seeing it on my screen right now. It's a standard graphing calculator like y equals 2x plus 3, and you can graph a line. That's awesome. You can also use function notation. So this is the same graph with function notation, and you can use that, that function definition. You can define points based on that function definition. So this is 1 comma g of 1. You can label the points. There's so many things you can do. You can do inequalities. So this will graph all the y coordinates less than the function. You can also graph multiple graphs on one graph and investigate where they intersect, where the intercepts are. Usually, many of the most important points are clickable, and they bring up the coordinates very quickly for students. A nice one is that you can limit the domain of a function or the range of a function. So in this case, I've limited the range of this function to only the y values from 0 to 2. And you can combine functions using function notation and graph the combination. Where Desmos comes to life is an example like this. Let's say you're teaching parabolas. Okay, it's nice to graph a parabola. But where it really shines for kids is when you change. So notice my vertex is 1, 1, but I'm going to change that 1 to a k. And what I did was I just up in the left changed it to a k. You notice it says add sliders. So if I click on that, I now have the ability to parameterize that, to change that parameter. And kids can slide this to see what k does to the graph. And it's very simple to do things like limit the domain from -1, like -2 less than or equal to x less than or equal to 2. And now I've limited the domain to only be that part of the graph. And you can even do other things like change this to, I want the domain to be h minus 2, whatever the h is they choose, to h plus 2. And, oh, excuse me, I meant k. And so now if I slide it, because of the way I changed this, now they can see the transformation that happens with that k parameter. And of course, you can make as many as you want. I guess I should have done, usually it's h in the middle, and I did it backwards. Oh well, you'll get the point. Teacher fail. The one on the inside makes it go right, left. The one on the outside makes it go up, down. We could have a discussion about this. Desmos does implicit graphs, the exact same graph in parametric form. I need to have my t-value go to 2 pi. You can do parametric versions of graphs. And then you can do fun things like what happens if we make the parameter, like instantly they get visual feedback of what's going on. Or even cooler is like something like parameterize the thing inside of sine. And now we can look at, oh, we can do animations of what happens if this parameter goes crazy. So for you pre-calc and AP calculus teachers, parametric functions. This is the last little example I'm going to show you, and then we're going to go to Activity Builder. I want to show you, let me back up for a sec. The ones I've shown you are kind of simpler examples, kind of like gradually getting more complex, but here is something I have built, and I've built tons of these, and I've shared all of this with you. I've shared way more than I'm going to show you today. So I teach pre-calculus and AP calculus, and here's an example when I'm teaching the unit circle and teaching analytical trigonometry. Sometimes students have trouble visualizing, like, why does the circle become a wave, and how does that connect to a right triangle? I've created a little activity where they can hit play and they can see as I hit play, it spins around the unit circle and the y coordinate is shown in orange. So when they turn on the sine, like if they start this over and turn on the sine animation and hit play, now they can see in real time why, if you spin around the circle and plot the y coordinates, it comes out as a wave. This would come after an activity where they were painstakingly doing this by hand. So I would have them do it by hand and then say, what does this look like in general? Let's press play. And then the natural thing is to also do it for cosine. And I've got it set up so that they can investigate this in real time. So this would be a slightly more advanced example. You have access to it. By the way, if you want to see how I built this, all you have to do is open these folders. And the code I used to create the example is actually shorter than you might think. The cosine example. So you can go investigate this, copy, use, learn from it. Briefly, let me say that I also shared an activity that is a roller coaster activity, which has a link in it. And it links to something else I built that's a little bit on the next level. And it's a discussion I have in pre-calc about increasing and decreasing functions, but we do it in the context of when is the roller coaster going uphill and downhill. students are asked questions in the activity about where does it reach its maximum point at the middle hump, and when is it going downhill, when do you think it's going the fastest, all that kind of stuff. And we have fun with it. This activity and this link is available for you to check out, but this is the kind of thing where Desmos takes that next level. This beats TI-84 hands down. Okay, so let's say you want to go make something. So this is just like me saying, please go learn about Desmos calculator. And there's tons of amazing videos out there helping you, let me pull up, helping you learn more about that. And I've linked many of them to you. Okay, so let's say you want to start from scratch. Okay, David, how do I do something simple? Well, you go to teacher.desmos.com. That's where you start. You create a login. And the first thing you can start doing is making your own. And I'm going to show you. Here's custom. So by the way, something I should say. What I just showed you was the standalone calculator app that you can use online. But you can save. You can also log in here and save every graph you make. And I have tons of them saved, And you can pull any of these into a Desmos activity like the one that you were working on earlier. Okay, let me show you. Okay, so this is the home beginning page of Desmos Activity Builder. And it's so simple to get started making your own. You just click the custom. So this is really your starting point. Down here, you can search for pre-made things and borrow them and use them in your class. They're amazing. But if you click on custom, it takes you to the ones you've made, and you can start a brand new activity. And I'm going to start a brand new activity from scratch. So I'm going to call it my first Desmos. Start building. It's kind of like PowerPoint. And you can have a basic thing like solve an equation. This isn't going to be fancy. And then you can start adding the features you want in your question. Like I could have a note, solve this equation. And then have an equation like there's a math button. If you want to make the math look nice, you can go x plus 3 equals 7. And then you can make it multiple choice. You just click on a thing and you just populate the answers that you want for the multiple choice. You can do like x equals 2, x equals 3, x equals 4. And if you want to be able to evaluate how many students are getting it right, you want to select the correct answer. They won't see the correct answer, but when you go to that like summary screen, you can quickly see who's getting it right. So this is for you on your side. You can also randomize choices. There's so many options. The multiple choice can also prompt students to explain their answer and show students their responses for their explanation. Okay. If you don't want it to be multiple choice, you can just do input and have it be text input where they got to type it, or math input. If you want to preview what it looks like, you just hit the preview button and you can see what students see. So you can check and see if it looks the way you want it. Couple simple examples. What if I want to have a graph that students can draw on? Well, hit the graph button. It brings up an editable graph. And I'm just going to do y equals 2x minus 5. Awesome. Now I'm going to make a question. It's going to be in a note. A note is usually how you make a question. And it could be like, what is the equation of this line? Input, math. I just made a problem. Done. Preview. There you go. Now let's say, oh, you know what? I not only want this, but I want them to draw on the graph, not just like look at it. I can go back and edit it. Instead of this, I'm going to take away the graph and you go, oh, you know, I changed my mind. I'm going to make it a sketch. Pull in a sketch. Do you see the background option here? you can make the background any graph you want or any custom image you want. So you could pull in a picture, you could pull in like a picture of somebody shooting a basket or shooting a basketball, and it's mid-air, and you're asking, will the arc of the ball, do you predict it'll go in the basket? And they could plot like a parabola over the top of it. There's all kinds of things you can do. But I'm just gonna make it simple, and I'm gonna change it to this. So it's an editable graph, and I'm gonna put in, I can't even remember what equation I put, but it doesn't matter. So I'm just gonna do what, I think it was like -5, it's all good. I'm gonna hit done, and now it could be, what is the equation of this line? Also, draw a parallel line. So now it's a question where they can put in the answer to the equation, but also you've asked them to try and draw a parallel line. So you can assess their understanding of parallel lines. You could ask a follow-up about how do you know these are parallel? Tell me something about slopes. Awesome. Okay. There's no way I can go through a ton of examples. So here's what I did for you. And I will go through a couple more, but here's what I did for you. You remember I shared my collection. I'm gonna keep this open. So I'm gonna open in another window. I'm gonna go to teacher.desmos.com, and I'm gonna go to my collections. I'm gonna show you what you have. You have access to this basic examples one that I made. This basic examples is a Desmos demonstration of a ton of stuff you can do. So you have access to pull this into your own. Once you make a Desmos login, you can copy this to your thing, and you can look at student examples of all these. But even better, I would say hit the 3 dots in the upper right, edit the activity. And by editing the activity, you go in from the teacher side, and you can start going through a ton of examples. Oh, sorry, I hit the wrong button. Edit my activity, and I meant to hit preview. You can preview as a student, or you can page through these and see all kinds of questions that I've created and examples of tons of questions. For example, and let's look at a couple. These are all available to you. Let me page through just to show you a couple. Clearly multiple choice, multi-select, how do you make it? Your multiple choice can be graphs. So the question, which graph shows this equation? You gotta come down and find the right one. There's so many options, and I don't have time to show you all of them, but it's here if you wanna go try to figure out how I did it. And it'll kind of give you a way to say, like, go YouTube search, how do I do this in Desmos? And I guarantee there's a cool teacher out there who has made a video on how to do that one thing you need. I want to go back to this. Okay, so this was the one I was making. I was making it from scratch. I want to show you a few more features of if you're making your own activity. And it's possible that on the call right now, there are some department leads or curriculum coaches or administrators. Hey, if you are creating content for your schools or your district, when you make a page, there is this little light bulb icon in the top right, and it brings up teacher moves that you could suggest, sample responses and common errors, student supports. You could put standards and CMAP alignments for your curriculum map, all kinds of stuff to save these in a really organized way and share them with your fellow teachers. Let's see, I wanted to show, there's one thing I wanted to say that's not obvious. It is in the examples. If you want students to be able to use the Desmos calculator, then the graph has to be the only object on that page. If you add a note or anything else, the graph is not editable to the student. So like if I say, okay, questions, let's say I have a question here. The students can read the question, they can see the graph, but they can't edit it. They can't click on it. if you want the students to actually work with the graph in Desmos Activity Builder, you need to not have anything else on the page. So how do I facilitate that? There's kind of two ways. What I'll do sometimes is I'll plan ahead that during the lesson, I'm going to restrict them to screen 3 and 4, which you see on the left. And screen 3 will be instructions, like on the next page, graph, whatever. Put instructions for what you want them to do. And then on the next page, if you only have this, then if I do student preview, you will notice that students on page 3 have your instructions, and on the next page have a graph that they can work with. And now they can actually play with this. Like they can graph like y equals 7, or horizontal line that I can't see because I need to zoom out. So that's one suggestion. Another thing, what you can do is you can actually put instructions in the calculator. So the lines in here can have text. If you hit the plus and hit note, you can give instructions here. Graph the following, and give your instructions in text. I do that often. And have follow-up questions. Maybe you have some questions. Although also if you just hit the quotes, it just brings up the text, and you might have a question 1, question 2. Maybe you want them to do it on paper. Maybe it's homework. Okay, so those are options you have. So that was one thing that was not obvious to me when I first started making these. Let's say we've made this lesson's not very complete, but let's say we finished it. All you have to do is save it. Next, you can describe it, change the title, add an image if you want to have a nice image that's associated with it, and you can preview it and hit done. What it does is it puts it back in your custom folder. If I clicked on that, it would be in there. What you can do is you can come over here. You could add this to whichever collection you want. Like maybe this was a Math 1 lesson, so I'm going to go dump it in my Math 1 collection and hit save. And if I hit collections, I can go to my Math 1, and my first Desmos is hiding in there. And so now it's collected for me. Now let's say class starts right now and I want my students to go in and start working on my activity. I just click on this, create a class code, view dashboard, restrict students. I'll do the restriction thing, pacing. And then what you can do is you can say, oh, I really only want them to work on number 1. And maybe number 1 also has a discussion element. So you want to get them talking about an idea. I'm just going to restrict to screen 1. And then I'm going to say, hey, students, go here. And you already got your warm-up problem waiting for you. And that's it. That's really that simple to make something and get started with just sharing and getting students working. One thing, in the resources that I've shared with you, Desmos has on page 2, they have a learning website that really goes into detail about how to make each one of these things. So if you go, oh, I know David said that I could make a graph and they could draw over it, but I can't remember. They have videos on all of that. They're really nice. And the link is in the resources. Okay. Now, here for the rest of the talk, and this is where Desmos is really takes it to the next level for me, is how I use it with my students, both online. I can see some students join my lesson. How do I use this with my students, and how do I use it in the live classroom, and how do I use it online? Okay. You can already kind of see how you'd use it online because I can restrict the screens and make sure they're working on what I want them to do. But what I'm going to do is I'm going to show you a different example. I'm going to go back to my Desmos home screen. I'm going to go to collections. I'm going to go to my Desmos demonstration. And now, what I'm also made for you was basic activity ideas. And I want to show you some. And I don't want you to go into this because I want you to see what I see. So, I mean, if you really want to, you can, it's okay, but don't go into this yet. Do you see that there's 3 students here? What I did was I went into an incognito window, and I created some mock students. Actually, there's only 2. I had a little mistake, and it looks like there's 3. So I'm gonna go into the view dashboard. So let's say my class is doing this activity. Here are some examples of activities that I do inside of Desmos in my class. I've got 2 students in this class, and what I want to get at now is, how do we use the tool to go deeper than just basic math questions? How do we get them talking? How do we access those higher order thinking skills? How do we look at deeper depth of knowledge? What are some things to do? I'm going to give you a few ideas to get you started. First one is, have them explain, both in words and groups and in Desmos. So what I like to do is, for example, is have a question like this. Explain how you would try solving this equation. Don't solve it. And if you're not sure, at least write what you would try. And so they've got this. Now, as students are thinking and typing, you can look at the summary of what, oh, excuse me, I can go to, I was already on it. The teacher tab in the top shows you what students are typing in real time. So as they're typing and editing, you can see it happening in real time. And you can start to look at different answers that students might come up with. And you can highlight those different answers in a discussion. So I would restrict them to page 1. And after students have had some time, if this were a live class, I would probably have each group of 4 say, hey, talk about what you typed. And then some students might start editing their answers. But then I would bring it together as a full class. And what's super cool is you can just pull this up on I have like a projector in my room, and I would just project these and notice that I have the anonymize on, so nobody knows whose answer is what. And I could say, hey, look, this student said they were going to use the quadratic formula. This student said, I'll graph it and find the x-intercepts. Another student might say, hey, I think I can factor that quadratic and use the zero product property. And so students can share their ideas. And then in a follow-up, like on page 2, I might say something like, now solve this quadratic using any method mentioned by somebody in the class. And one student might go, oh, I was going to use the quadratic formula, but graphing sounds fun, so I'm going to go do that. And you can give students options by doing something like this. You hit the pacing, limit only to these 2 screens, and you'll see why in a second. I'm going to stick to the 2 screens. And now it says, solve this using anything we just discussed. Put your answer in the box below and describe which method you choose. If you want to solve this equation graphically, you've got a blank graph on the next page. Feel free to use it. You don't have to. If you want to use an algebraic method, go for it. So some students may come over here. And in fact, this student decided to graph it and find the x-intercepts. But the other student who said they wanted to use the quadratic formula, they put their answers. And then this is one of those questions where it also prompts them for what they did and like what the reason was. And this person said, I used the quadratic formula. This person said, I graphed it on the next page. And you can quickly go look at the summary and quickly see, oh, what did Adrian do? Like here's the answer. And then on the next page, they graphed it. So this is one way to like ask a question that gets a discussion going. Put them in breakout rooms. If you're in Zoom, try breakout rooms. If you're in a classroom, give them choice. Sometimes choice is not appropriate. You really need them to learn a particular way of doing a thing today. Sometimes choice is amazing. Both are useful in different circumstances. Then we could say, all right, time to move on, totally new. So I'm gonna stop. When you hit stop, it lets students go anywhere. Let's get some SMP 2 and 4 going. Let's decontextualize a situation and model. Rebecca's saving money for college. So it's a standard linear equation word problem. Enter your equation below. Notice these two students have expressed equivalent linear equations, but in different forms. Check this out. Let's say you want a discussion about that. Who's right? See the little camera? You can click on the camera. It just took a snapshot. Click on the camera. It just took a snapshot. Check this out. See snapshots too? This is so cool. Click on the snapshots. And now the pictures I took, by the way, my dog is barking at the UPS guy, so I'm sorry. Life in the online classroom. Do you notice the two snapshots I took of these two answers? You can come over here and drag them into an activity like that I'm gonna do on the fly based on the formative assessment I'm doing. You can also do this when you're seeing that a lot of your class isn't getting a thing. You could put up incorrect answers and we can start discussing how to make them better. And I can just make a question that says, who is correct? I'm just gonna like leave them. I'm gonna say, hey guys, I'm noticing different answers. What's up? And I'm just gonna blast this on my projector and say, you've got 1 minute to discuss with your groups. I saw these two different answers. Who's correct? And of course the answer is, they're both right. They just use the commutative property of addition and did it in a different way. And somebody might say, hey, she started with $400 and she's saving $100 per week. This makes more sense to me. And somebody else goes, yeah, but we learned at y equals mx plus b, so that makes more sense to me. That's the discussion you want to facilitate. And Desmos allows you to do this. Notice it even removed their names. So if you really want to make sure they don't even know, like you want to make it super safe, you can always use snapshots and then bring up student examples like on your TV, or if you're doing the distance learning, you can just bring it up on the Zoom or the Google Meet. Love that. What I often do is, oh, by the way, part of this question, I didn't say it. Part of this question was not only to answer it, but on the next screen to graph the result. And this is a case when I'm asking them to actually graph it. And this is a case where I actually put the instructions on the left-hand side. And for some legendary bonus points, so my class, I always try to have, like, best I can, like high ceiling, low floor activities. So if there's that student who really wants to shoot for like that extra, maybe they're really techie and they want to try to figure this out, I said, hey, adjust the axes scale. Not only graph your equation, that you put on the previous one, but adjust the axis. It shows the important values. Add labels to your axis. Do negative weeks make sense? You could have a discussion about that using snapshots. You know, how long does Rebecca have to save money before she goes to college? It said it was 1 year, so it's 52 weeks. And by the way students do this, I didn't talk about this earlier, is students can edit, anybody can edit the graph parameters by clicking over here to the graph settings and labeling the axes and changing the scale. You can give the axes names, change the grids and everything. So if I want to say, hey, what are my students doing? I can go check out, hey, what did Mina do? Awesome, Mina graphed this. And do you notice that Mina changed the scale to show 52 weeks along the bottom? And Mina labeled it time and labeled the vertical money. Now, this would be a graph that I would likely project in my room, because I would say, this is amazing, it's correct. It did exactly what I asked. Now, how can we take this answer and make it even better? Why not, and why don't we add the units of money and the units of time in the name of the axes, just so it's even clearer and we have that discussion. It's a great way to just project an answer and say, this is correct and if I go, by the way, there's a fast thing here. If you look in the very upper left, it says Mina Reese and there's that little arrow. If you click down, it just goes to the next student. So you could quickly go through student answers on that one question really fast in class. And you notice this student took that extra step of limiting the domain of the function for 0 to 52 weeks because it was a 1-year problem. So now it's just limited to that. And then here's an example of money in dollars and time in weeks. I have a little sneaky teacher thing you can do. If, and I've done this a lot, well, I've done it a little bit and I need to do it more, is actually, if you open up a Chrome tab in an incognito window, you can log into your own Desmos as a guest at the same time you're logged in as a teacher on the teacher side. And then you can populate an answer, a set of answers that you want to use as like a devil's advocate answer. So you can actually be a fake student in your class and students won't know because they're anonymized. I mean, they'll probably figure it out eventually that you have a tendency to be the sneaky teacher. So you can incognito window your own answers. In fact, that's how I made up these answers for this demonstration, was I opened up 2 incognito windows, I logged in twice, and I populated it with answers from different students, different fake students. Sometimes what I do is after they've been working on these 2 pages on the Rebecca model is I will actually, I'm clicking on the student so you can see what the students see. I will actually put an answer, like an extra answer. So what I did here was I labeled it like what the teacher would do, you know, amount of money in dollars, time in weeks. But I actually labeled the endpoints with what they mean. And like I added on even, like Rebecca will have $5,600 after 52 weeks. Some students, like that wasn't required, but some students will see that and they'll look over here and they'll go, how did he do that? And they'll just organically start doing this on their graphs as long as they have examples, even if it's not required. You could then instantly do the opposite. Now, I'm gonna give you a graph. You tell a story. There's a graph on the left. It's totally abstract. SMP2. Now we're going to take an abstract graph and we're going to contextualize it. We're going to go the other way. Here's a graph. Go click on it. It goes from 50 down to 0. You know, tell a story. In your story, what does it represent? What does the horizontal axis represent? The vertical axis. What does the rate of change mean? And this is a good one to have students like think group share or think pair share, is come up with an idea depending on your class. Sometimes what I'll do is I will have a group come up with a story together and then type up their individual answers so that you know that everybody in the group understood the context of the story. Really good for EL support if you've got students that support each other in translation. In my class, I teach at Latino College Prep in East San Jose. Students can answer in Spanish, totally fine by me. But tell a story, And you can look at examples of students. So, you know, Haziel was selling baskets of nachos to raise money. He had 50 baskets. He sold 4 baskets every 2 minutes. I had 50 math problems to do. I did 2 problems every minute. You could highlight why 4 baskets every 2 minutes and 2 problems every 1 minute would be the same rate. But the first one makes a lot of sense because of the way the grid lines are on the picture. It goes down by 2 and over 1. Or excuse me, it goes down by 4 and over 2 if you read the axes. So a couple more quick examples, and then we're done. So we're right on pace. I just want to show you like things that I do to get those talks going. And I just want to pause and say a thing. When it comes to math teaching, this is probably true in anything, but flashcards for vocabulary, they have their place. Having a reference sheet on the table, I totally do that. I have a vocabulary reference sheet on my table ready for kids to grab. Making a word wall and doing posters, amazing. That's a great thing. But kids go that extra step of learning academic language when they are producing it in writing and in speech. And so if you can use Desmos as a way to facilitate that via writing and via talking, it really helps not only their academic language, but when they use it in context, they remember it. It sticks in their mental schema for longer. Okay, so that's what really this is designed to do. Couple other examples. Oh, this is an easy one you can do so fast. Here's the question. Consider whether the following statement is true or false. I love doing this. Quote, if you divide the unit circle into 4 equal sectors, then each sector will have a central angle measuring pi/4 radians. I would send groups of 4 to read this. This would be for pre-calculus. I would send groups of 4, maybe algebra 2. I'd send groups of 4 to go discuss this sentence and decide, is it true, false, and why? And after they've had discussion, I'd say, all right, time's up. I want you to start writing something. Explain what you think. Explain what you think. And notice what I did was I created a drawing on the left, and it says, explain below why you think the statement is true or false. And you can draw on the circle to illustrate your ideas. I'm not telling them to have to. If they want to, if that helps them, great. Some students aren't sure how to say it, but they can draw it. So you can get assessment, like when you're looking at students' answers on the fly, you can say, they are drawing the right thing. So I know they know that this is false. I know they're drawing 90-degree angles or pi/2 angles. I can see that, but they're having trouble formulating the why. Okay, so this allows students to access multiple ways. So a quick example, you might get 2 completely different answers. In fact, this was an example I borrowed from a lesson I taught this year. I made it up in this case, but it's brought from it. First student says false. I drew 4 equal sectors. Each one is 90 degrees, which is pi/2, not pi/4. That's this picture. This student looked at it another way. False. You need to divide the circle into 6 sectors to get pi/4. So these 2 kids kind of like deconstructed that statement 2 different ways and explained why it was false with 2 different arguments, and they're both correct. Again, a great follow-up for a snapshot. These are like amazing answers. There's lots of ways to approach logic. Another easy one, and we have 2 more examples and we're done, and we're going to be right on time. Another 2 easy examples that I love to do is, and the first one now I'm doing is sometimes, always, never. I love this. And you can make sometimes, always, never. You can take it down to any level you want. I'm going to go to the student version. This would be like probably a pre-calc sophistication, maybe, well, algebra 2 and maybe math 1. It just depends on what you think your class can handle. Explain whether the following statement is sometimes true, always true, or never true. If it is sometimes true, provide an example that makes it true and an example that makes it false. And in an activity like this, I would probably have 10 of them. Some would be true and false, and there'd be like 2 really good ones for the discussion that are sometimes. And it's the sometimes that really gets kids thinking. So the question is, or the statement is, when you add 2 irrational numbers together, the sum is irrational. And you will see kids debating like, oh, you know, add pi and pi, it's 2 pi, square root of 2 plus square root of 2 is 2 square root of 2, that's still irrational. And they'll have debate, like get a debate going. And then you might get things where students might not know, and that's okay. And then you might have a case where you might stump them all, and then that's a good teaching moment. It turns out it's sometimes true. If you add pi and pi, you get 2 pi, and that's irrational. But square root of 2 is irrational, and negative square root of 2 is irrational. And if you go square root of 2 plus negative square root of 2, that equals 0, which is a rational number. So it turns out this is a sometimes. But the point is to kind of get a conversation going about what makes it true, what makes it false. They got to come up with examples. All of this is analysis and evaluation. These are quick, like 5-minute activities that get at higher order thinking, that get at like language demands, that force them to use the vocabulary. And then last thing, 30 seconds, and then I have one example that you can look at. I'm gonna go to the student version. I adapted a CPM activity And by the way, I'm hanging out for another half hour, so bring your questions, anything you got. I adapted a CPM activity about algebra tiles by taking a picture with my phone and uploading it. And you can just ask them to draw figure 3. Just draw what they think figure 3 is. Explain the pattern you're seeing. And then how could you calculate the number of tiles for figure 10? So that's getting at that standard of mathematical practice of looking for repeated reasoning. And students will surprise you. It turns out there's 2 ways to look at this. It turns out you can add another layer. So you go 1, 1 plus 3, 1 plus 5, or excuse me, 4 plus 5, then you add 7, and you keep adding another layer. And it turns out you end up adding the odd numbers. I've had students see it that way. And then other students will go, oh, but it's just a square. So if it's 3 by 3, then it's 3 squared. And if you give students a chance to explain their reasoning, you might see like, oh, the first time you add 3, then you add 5. To get to 4, I added 7 around the outside. Or each time you go up one figure, you do the figure number squared. And you'll get students like using recursive, kind of like recursive inductive reasoning versus like squaring 10 to figure it out for figure 10. All of these examples are available to you. I hope I've kind of like gotten your mind going about how you could use this tool and how easy it is to make things. I'm going to just conclude the presentation here and just say that Desmos has really transformed my teaching. It also makes my lessons so much tighter when I have this nice format. I can move through things quickly, transitions are easier, and I'm using it in my online teaching actually right now. So thank you so much for being here, and I can't wait to hear your questions.
Great, David, thank you so much. I think this has definitely been informative, and I've been kind of looking at questions, and I've asked people if they want to stay and hang out and ask you questions. Now is the time, and they can type those questions into the Q&A, or they can type into the chat. Not sure if we're having hand raised. If we see that, we can do that too, I think. But let me go ahead and just start reading some questions to you. Is it possible to take a student input from one slide and use it as a parameter on a future slide?
Yes. And that is an area that I am learning about myself. But let me show you where to start. So when you log into, well, let me be a little bit more careful. Yes, there are ways to do it. I'm not totally sure how, but I know how I need to go learn it. And this is actually something that I want to learn. This is my next step in learning Desmos myself. When you go to the main page, if you click on the arrow, one of the options is Desmos Labs. Inside of Desmos Labs, you can enable the computation layer. The computation layer allows you to write scripts and to pull answers and auto check them to use answers that then get used in a next example. And if you go search for activities in Desmos, people have made them where like there's a game where they're trying to get like the ball to hit all the marbles and or whatever. There's all these kind of games, and they use this script and exactly what you're saying. And I'm learning that myself, but it is possible. By the way, last thing on this question, one of the links in the resources is to a webinar that was taught by, let me find the page, Julie Rulbach. And she did a whole Desmos webinar hosted by Desmos on their website, on their YouTube page, I mean, about how to use the computational layer to create quizzes and exams. And it's the same stuff you would need to do what you just said. I highly recommend you go watch her video. And then she has an amazing website with all kinds of resources at that level. It's deeper than I have experienced.
Great resource. A question I've seen pop up a few times is, do you think Desmos is useful with lower grade levels besides high school, like down to 6th grade, or what would you recommend?
Desmos is as useful as your creativity. I would say that it just depends on what level you want to. So clearly some of the graphing calculator stuff of parameterizing functions is going to be at a level that's above, like, say, 6th grade. But you can still use Desmos to do, you can use tables, you can use pictures and drawing. It definitely is going to lose its effectiveness the lower you go, because it is kind of tailored towards middle school and high school. But if one thing I would suggest, because I'm a high school teacher and have taught at San Jose State. So I have lived in a world of upper grades and upper level of teaching math. What I would highly suggest is go to Desmos and start searching through the activities. You might be surprised at how many there are at levels that are in lower grades. And so we can even look at, a lot of them are going to be grades 6, 7, and 8. So distance learning grade 6, they have examples. Balloon float. You might look at this and go, I don't know, do I like this? Student preview. And then you go, there's a video. And then what's the first question that comes to mind? Looks like there's some kind of interactive thing with, so some amazing people have created some awesome things inside of Desmos. And then let's say you love it. Well, guess what? You can just come up here and go plus, and click on this. And then you just copy and edit it, and you can put it in your collections, or you can just create a class code directly from this page and just try it.
Okay,
somebody mentioned in chat the card sorts. That's a great idea. The card sorts are fantastic. Positive and negative numbers, all kinds of card sorts. Yeah.
Good. I think there's been a few questions as I'm monitoring both here, kind of about using this with remote learning, like with splitting screens or sharing screens. Do you pop into a Zoom and have them discuss things? Like,
yeah.
How would you address that?
Well, I have a setup. So, okay. What I would do, like, first level is assuming you're in Zoom and that you can put students into breakout rooms. Personally, that's what I would do, is I would try to decide what are my intentional groupings, what size groups do I want, and then I would try to pose questions that are gonna have an element of that group discussion. And yes, I do like to hop, and I'm doing that right now with my online course I'm teaching. Now I'm teaching adults right now, not kids, but I would hop and monitor those discussions and just say, hey, you guys are on the right track. Like, put your thoughts down in the Desmos box. What I tend to do is I tend to give them, like for the online thing, I will give them the code like I did to you. And then I'll say, hey, everybody come back to the Zoom so you can see my screen if I want to do a little lecture time. Now I have a setup I can show you real quick. This is, so what you can do, like I have it, maybe you can see it. I have a dot camera. There's a dot camera right here and I have it on, and I just have, I have whiteboards that I just put under here with some fine pens. And if I need to go into quick lecture mode and show them examples with graphing, I'll just switch my camera in Zoom. And I have a fancy setup with something called OBS where I can switch back and forth really fast. But you could just do something simple where in Zoom, you can actually switch your camera from your like camera or your camera up here, and you can switch to a connected doc cam. That's the way I do it. I hope that answered the question.
Yeah, great. Just kind of popping through both here, trying to find the best questions. Oh, here's a good one. And they're all good questions, of course, but I'm trying to group questions.
Yes, of course.
Yeah. Does Desmos make it possible to see a history of student responses so you can see if someone has changed their answer? I think that's interesting.
Oh, that is interesting. I don't know. So it turns out I have never used Desmos for formal assessment. I've never ventured into that because it turns out the school I taught at had an online platform for testing that we had to use. So my mind with designing Desmos has always been assessment for learning, formative assessment in the moment. And so I have always said, if you want to go back and edit, awesome. So I don't know. I would have to, I know that here's what I do know. I know that there is a history button, and I think I'm still sharing yeah, I am. There is a history button, and you can go back to codes of old classes. And I would have to look and see if you could like lock a student out so they can't further edit it. And I don't know.
Yeah, and I think the kind of a little follow-up to it was really just kind of thinking about like supervision, like with middle school students in particular, discipline issues, like are they cheating, I think is what maybe the question is getting at.
100%. Yeah. Yeah, that is an issue. Here's what I will say to plug the Julie Rulebach video I talked about earlier. She talks about strategies for fidelity for work. I know she talks about it. I don't remember. I honestly don't remember the details. So I'm going to have to defer on that one. I'm not sure. It's a really, really good question. It would be something to consider.
Here's something that came up that I thought was interesting too, especially as we're talking about academic language and working with EL students and such. Does Desmos, are you able to use spell check? Does it adapt?
No, let's see. So I do it so automatically without thinking about it. When you're making an activity, like if I go into this, does it, does it spell check on my end? I'm curious. So it does alert you to errors in spelling. And it brought it up via Chrome. So this is really like Chrome catching it, I think, not Desmos. So it may depend on, I think, I have to check that. Now, on the student side, if they're using a Chromebook, and well, this is a bad example, but if there was one that was a text box, let's say I changed this to a text box and I did the student side, could they like, you know, maybe they spell parabola wrong, and then, you know, if they right click on that, so it works in Chrome. Probably like if it, like my kids have Chromebooks, so I would probably talk to IT about how Chrome interacts with this, and then see if there was a way to use those. At my school, they've got some kind of an app that some EL students have that will search text that's on the page and do some quick translations, or there's also apps for students that have, you know, visual or hearing impairment, things like that. So that's the best way. Yeah.
Okay, I think this is a valid question here. Is there a way to have students discuss through Desmos, like with text?
In discuss, no. There's no like wiki style multi-editing. There's no back and forth like chat box. If I wanted students to do that, so the answer is no. Desmos allows them to put an answer, and then you have the ability to allow students to see other answers. What I would personally do if I really wanted that was I would look for an exterior app that did what I wanted, like say a Google Doc, where they could group edit a Google Doc, and I would actually share the link in a note box. And you may notice that the example, and that's doable. So for example, the example I started with for you guys had a little homework assignment at the end, and the homework assignment at the end of the example I gave you guys actually had links, and you can link outward to anything. And so you'd have to instruct them to like go do the thing over there and then come back to Desmos.
Great, okay, that makes sense. Here's a question. Can you create function tables in Desmos in a Desmos activity?
Yeah, sure. Let me show you. Anything you can do in Desmos graphing, you can do in an activity, because they're the same tool. So let me answer, there's kind of like two questions there, in a way. So let me show you. So for example, if we go to custom, my first Desmos, I'm going to edit this and I will show you. I'm going to edit the draft. Okay, So I'll go to a new one. I want to actually show you, or I think this is what your question is. If I go to just Desmos and I go to the normal graphing calculator, now I'm not in Desmos Activity Builder, but I'm going to show you something. So now I'm just learning how to use the graphing calculator. There's a couple ways to do it, to do function tables. So one is I can go f of x equals 3x minus 2, or minus whatever. There's a gear symbol, and the gear symbol brings up more options that I did not have time to discuss. And one of them is to convert a function to a table. And you notice it's graphing the points. You can hide the function too. It's because of the way this is set up, it's graphing. I think there's a way to make it so that it only graphs the points and not the lines. Yeah. So there's options on all the things that are clickable. And so now the points that are shown are from the table and they come from this function. But they're, and so that's one way to do it. And you can easily add more values to this. So you can come in here and edit the table to be any real value numbers you want. Now, how would you get this now? So what I tend to do sometimes is I'll just play with my ideas over on the calculator. And then I go, you know what? This is my function table, and I save it. And now it's saved in all my former ones. And then let's say you want to share it, like with yourself or a colleague. There's a share button. And there, it gives you a link. And this link will always stay fixed. This link will always take you to exactly what you see on the screen right now. And so if I hit copy, and I come back to my activity. So now I'm saying I want to import that one thing I just made into my activity. Oops, I'm going to go to the other one. So now this is my one that I made. I'm going to move this down to the bottom. It's going to be on my last page. So I'll click and drag that. So this is my new page. And here's how you do it. You just open up a graph object. And then in here, you actually just paste, you paste the URL that I just copied. I already copied it, so I just hit Control V. I pasted. When you paste a URL into a Desmos line, if the URL is to another Desmos activity, just pasted what I just made into this. And so you could show the picture. You could show it. You could show it without the without this, so that they can see the table and the definition. And if you only want them to see the table, you can also just create a function table and do it that way. So there's multiple ways to deal with tables.
Great, thank you. I have a question here, I think asking for a recommendation, probably your opinion. I'm just gonna read it to you. Great presentation, David. We're all enjoying this. Love the incognito fake student idea. Desmos calculator can make the TI, 84 feel clunky and hard to use.
Yep.
But Desmos isn't allowed on standardized tests. So
Yep.
do you have a philosophy on when to switch over to TI 84?
Yeah, so I taught AP Calculus this year, and so I actually needed to train my students this year on the TI-84 because first off, my school didn't have them the previous year, and most of my students had never experienced the calculator, but they were really strong with Desmos. So I use both side by side all the time. In terms of those standardized tests for now, I would suggest at least introducing the TI calculator, maybe sophomore year. That would probably be my suggestion. It totally depends. If you have an advanced Algebra 1 class or 9th grade level or advanced kids, that's great. I think there's, the reason I say that is because at the SBAC, I know things went weird this year, but if that comes back, sometimes they have an embedded calculator that could look a little bit like Desmos, or it might look like a TI. Can't always tell like how they're gonna change that. So I would suggest starting to introduce it at sophomore level. They may not need it, but I have found that the shift to TIs can be a little jarring. But students are pretty, if you create some, you know, activities of syntax, they take to it pretty fast. Kids are pretty tech savvy these days. I do want to say a thing though. I have heard people say, then what's the value in teaching TI syntax? Like, isn't that kind of a waste of time? I actually say no. It's actually worth it to use Desmos for all of its strengths and to teach them to interact with older technology. And there's two reasons why. One is they need to be flexible on using different technology for its different purposes. And TI syntax is actually closer to what they will need to do if they ever pick up a programming language. So if they're going to program in Python or C++ or do any JavaScripting, they're going to need to use syntax that's way closer to what TI uses, and that experience will help them. They need to be much more precise in where they put their parentheses. Desmos is very forgiving with those kinds of things. So I think there's value in introducing both.
Great. I think I have a few more questions here. Question I'm going to read to you from Veronica is about, does Desmos have a geometry construction tool? Does it have tools for measuring angles, arcs, etc.?
Yes. Desmos, it's a little bit hidden. They don't call it out. And I will say that it is basic. Here's one where there are more powerful tools. For example, GeoGebra. But if you want some basic constructions, it will do circles, and you can add points to the circle. And you can do various constructions. It'll do you know, line segments. You can do angles. And you're able to like turn off the angle or turn on the angle and change these. So absolutely, you can do simple constructions. You can do really fancy things. As far as I know, unless there's some advanced thing that I don't know about, there's no way to pull the geometry, the Desmos geometry into the activity builder. I'm going to be careful there. I actually don't know if that's possible. It's not obvious. So in the interface that I showed you, there's no clear geometry button. It's possible with the computational layer that there's a way to do it. But again, that's kind of like even beyond what I know and what I've used. But the tool is here, and I have absolutely used this when I taught math too.
Great, thank you. And I think this might be the last question here. Is there a way to export images from Desmos graphs or embed the graph itself in, for example, a PowerPoint presentation?
Yep, multiple ways. And you can even go further. If you have a website, there's an API where you can actually embed all of this in your website. So if you make a Google Sites, there's a way with a little bit of HTML you can do that if you want to get super fancy. But if you just want to go basic, I can go to a function. I can take what I graphed. Let's just say I create this super cool graph that's like, you know, x minus 3 and x plus 2. And I need to think, so if you hit the share button, I think one of the options is to export image. Now, sorry, I turned off the graph so you can't even see it. Two bits of advice. So the truth is I never use this. So I don't know, we could try it right now. Let's export it. Oh, this is new. Medium square, I guess. Oh, if like you need to think about thickness for a presentation. Oh, that's nice. This is new since I last used it. You can download in different formats. So this is pretty nice. What I do is I actually don't do that, although maybe that works for you, is I often just get it how I want it. And then in Windows, I just use like the snip tool and I cut what I want. And now I can just copy it and paste it into a Word doc or whatever I want. And that's really fast too. So you can choose any method you want. And to add on, one of the features in the wrench is also projector mode, which sometimes makes it look nicer if you're in a big room and you're projecting a graph, and that may affect the visual. So there's little options on how it looks.
Great, thank you. I think that about covers it as I grouped the questions. So just want to pop on and thank you, David, I think,
Yeah.
wait, maybe we have one more question here. Was
Yeah,
the
no
snip
problem.
tool, was the snip tool on Desmos?
Oh, that was I'm in Windows.
Oh,
That was a
yeah,
Windows
okay,
tool.
got it.
And Macs have their own version. Mac has a snip tool. So I did that in Windows.
Awesome. Okay, well, I think this was super informative. I think by just monitoring comments and questions, you know, the people who were here really got a lot out of it. So appreciate it. I want to let everybody know that this has been recorded. You'll be sent out a recording. You'll be sent out the resources that David kept mentioning will also be shared with you, and also a feedback form if you could please take the time to fill that out in the follow-up. And if you're wanting to attend any more webinars, please join us in the next several weeks, and you can share the webinars with other friends or colleagues or people that you think might benefit from attending. So David, thank you. San Jose State is so lucky to have you. Really appreciate you being on with us today.
No
And
problem.
I hope, yeah, hope you enjoy the rest of your summer course.
Yeah,
and
it'll be fun.
yeah, good to see everybody. And I think we're going to close it for now. Happy Monday. Thanks for attending. Take care,
You're welcome,
everyone.
everybody. Thank you for coming.
Bye-bye.
Thanks, David.
Oh, thank you so much for hosting. I really appreciate it.
No problem. We'll see you.